Right, welcome to week 2. You survived week 1 and you're still hanging in there with me. This week's going to be an interesting one. We're really going to be putting some meat and potatoes on our plates this week. We're going to start with some vocabulary. And as we get into it, what we'll find is there's quite a bit of vocabulary that comes into play when you think about GIS. So what we'll touch on this week is we're going to look at, of course, this introduction. We're going to look at some fundamental concepts, very, very key, as I mentioned, meat and potatoes. We'll get into the key words so we have the vocabulary down. Then we'll take a look at the review for Project 1 and the access therein, and also talk a little bit about RRD1 and how you can associate the library and or Google Scholar to help you accomplish these assignments that are out there and kicking. Okay, so let's get into it. Let's take a look at what's going on in this two-part series. Let's start with this concept of theory and practice. Now, a lot of you have probably heard this before. In fact, you've probably heard it throughout high school. You've probably heard it in other science classes that you've taken. Theory is going to be defined as a set of rules for understanding how something works. Now, we've got to take a step back, right? Because a lot of you are saying, now, Cole, I don't trust theories. Those are guesses. Those are thoughts. As a matter of fact, if you think about a hypothesis, how has a hypothesis often been defined? As an educated guess. Well, a hypothesis really isn't an educated guess, but it's directly connected to a theory. A theory is a well-substantiated explanation of an aspect of the phenomena in the natural world. And essentially, these are things that we can observe that can incorporate laws, hypotheses, and facts. So take gravity as an example, right? Gravity essentially is connected with a theory, but we see it work time and time again, and you can't really disprove it because even when you're flying on an airplane and traveling somewhere, gravity is still present. Even when you're in outer space and you've got NASA and JPL doing all the awesome stuff that they're doing with things even out on Mars, or as they're doing these walks on the International Space Station, all those folks are still being impacted by gravity. So you can see how that theory is still there. Okay, so if we look at it, it's tied to the work of science and, in essence, scholarship. It's tied to the academics of being able to prove this, right? We're looking for patterns, we're looking for equations and rules or laws, essentially, that help describe how the world works and puts it in a way that we can digest it. It helps us to bring known facts, but it also helps scientists to make better predictions. And that's very key, especially as we get into GI science. Right? We want to be able to take in new evidence. We want to be able to take scientific theories that are in fact testable. And as we observe them, these things are true time and time again. Again, back to the idea of gravity, right? So new evidence needs to be compatible with an existing theory. If it isn't, then that theory can actually, in theory, be redefined or it can be rejected. Okay, so that's the big catch I think folks struggle with in science is that nothing is exactly permanent, so to speak. And the longer the central elements of a theory are held to be true, the more observations it's able to predict, the less we have to test it because it's going to pass more and more tests, everything that we throw at it, and the more facts that allow it to essentially explain that hey, with all this, it's explaining the world, so they're strong. It's a strong theory. It holds together. So take all that, digest it as best as you can as you consider what a theory is. In this case, we're looking for a well-substantiated explanation that can be proven time and time again. We're looking for patterns, equations, and or rules that describe physical phenomena of Earth. Okay, that's theory. Now, practice is interesting because it's an action towards a goal. Now, we've got to be careful because there's going to be some other vernacular that we're going to throw out here in a little bit. But when we think about a practice, I want you to think about the practice or the enactment of theory, the enactment of those patterns, the enactment of those equations, the enactment of those rules. So I have a bad habit of going out and getting pizza on Tuesdays. Maybe somebody has a habit of going out and getting tacos. My practice, my tendency to do this is that I look for the best deal. Therefore, as I find the best deal, I will constantly fall into that goal, accomplishing my goal, the best pizza at the best price, right? So this idea of practice now is tied to the work that technologists, explorers, thinkers, tinkerers, and just scientists in general, if you think about it, are often doing. They are the doers rather than just the pure thinkers. They're the people that go out and they do things. These are people putting theory to practice. They don't just sit in their stuffy office all day and theorize and teach about these things during the day, but they go out and they practice. Wait a minute, that kind of sounds like me, but not putting myself in the limelight at the same time, right? I work by day, I teach by night, in essence, to be able to take any of the theories, any of the rules and patterns and equations that I found to then apply or practice in the real world, both in my job, but also in instructing, okay? So that's what we have to consider this. But we have to also be careful because the distinction is not entirely clear cut. And more likely, theory and practice really go hand in hand when you think about it through and through. Okay, so that's the idea of theory and practice. Quite a bit to digest there. But then we have these other things that overlie or sit atop structure and agency. Okay, these things are, I should retract my statement earlier. Actually, it's this idea that theory and practice overlie the structure and agency. Whew, get that straight. So when we look at structure, this is that underlying set of rules that are there. They're rules that we observe in theory, but we practice within society. There are rules for how society works, how we should behave, and essentially how society is going to reproduce itself. No, not that reproduction. Get your minds out of the gutter, but in the sense that how society grows and how it changes or evolves through time, okay? It's a type of theory, if you will, structure is, that emphasizes the overarching rules of a society. Again, how does society function? What's socially acceptable? What's not? To post or not to post? That is the question on Insta. Okay, now agency incorporates structure, it incorporates theory, and it incorporates practice. But as we'll find out here in a minute, there's also something else that comes into play with agency. Agency here is the ability, essentially, for an individual to exert choice, the ability to choose, or someone who has the will within the social structure to be able to choose, okay? So this is an agent-based societal theory, meaning that we as individuals make a choice. Going to start sounding like Morpheus from the Matrix here in a minute, right? We emphasize activism, we emphasize change. That's agent-based theory. People don't like this concept of climate change. People are going to take an agent-based social action using existing theories and existing structure to incite change, okay? That's the idea there. Now, when we think about it, agent-based modeling is readily available in GIS, but we have to step back for a sec because this idea of agent-based versus societal structure, and we have to throw that caveat there that I'd mentioned just a moment ago, and that's getting us to these other definitions that we have to understand: objectivity and subjectivity. It's really interesting when I teach geology classes, in particular physical geology and historical geology, and even in teaching GIS, it's fun to talk about this because you talk about observations and interpretations. Well, essentially what they kind of are looking at objectivity and subjectivity. Objectivity is the idealized mental position for scientific study, meaning you have no bias. You have the ability to detect the world unrestrained, undetained, and unbiased, if you will, from your personal opinions or society's personal opinions. That's what the ultimate goal of all science is objectivity. The problem is, especially in society in this day and age, is this concept of subjectivity. That is the set of beliefs or self-feeling and satisfaction that we tend to inject when we are trying to make our observations, when we're trying to develop and identify theories in practice, okay? It's this idea that the myth of neutrality or objectivity is undercut by studying of race and gender. What's that mean? It means that, hey, if you're going to study racial discourse or you're going to study challenges about gender, even from a spatial science standpoint, odds are there's going to be some subjectivity there. You have a desire to study that, maybe because it's interesting, but maybe because you yourself or someone you know is impacted by these items. Okay, that's the idea. We want to make sure that our position in the world and how it affects how we see the world is known, right? And that's a good thing too. Don't get me wrong. I'm not saying that it all needs to be objective. Some of that subjectivity will actually really propel people into objectivity at times. But we just have to understand when we're doing our work, and we'll do we'll do an assignment later on in the semester that deals with voluntary GIS or VGIS. And that's where we have to be careful about separating objectivity and subjectivity. And you can see how all those can kind of feed back and really break down society, can break down agency, or it's the use of agency by choosing objectivity or subjectivity, but then also coming back and saying how it may break down our theory, right? So we've got to be very, very careful with that. So there's a whole bunch right there, starting to sound like a philosophical or a philosophy class, not what we're aiming for. But you do have to understand that these are the theories and practices behind GI science and geographic information systems. One of the key things, to throw some final verbiage out there for you, and then we'll give you a good example, is this idea of ontology and epistemology. Now, if you've studied any type of philosophy, you've heard these before. If you've studied some physics, actually, and also if you've gone through and studied any type of mental science, cerebral science, these come into play. Ontology, the philosophical definition, is the study of the categories of existence and the relationship among them. What? In GIS, what we're talking about is it's the classifications and relationships among categories. The way I want you to think about ontology is think about a big old filing cabinet. If you've ever been into the office at Cuesta College or an office anywhere else, you have these big old filing cabinets, right? And in there, they find your file. Okay, so that dates me, right? Who has a physical file anymore? But think about ontology as that filing cabinet with a selection of folders, okay? So it's storing what we know, but epistemology, the definition is the study of knowledge. How do we know what we know? How do we take that type of evidence so that we accept what we know? So ontology, again, is the filing cabinet, and epistemology is going to be like the information, the color-coded information that go in the color-coded folders within the filing cabinet. Epistemology helps us know these categories of existence based on clear-cut definitions. They help us decide, again, what goes in the folder and where in the filing cabinet. That's the difference between ontology and epistemology. Now, what gets really interesting, getting back into this concept of GI science in particular, is when we look at ontology and epistemology here, how do we define categories for real-world phenomena that don't have these nice color-coded borders, these crisp boundaries? Okay, it's really easy to go in and say, hey, this is where the boundary is cut off for a school district, or this is where the county is cut off, or this is where a state is cut off. Those are clear boundaries that have been surveyed. But what about things where you get into looking at the National Land Cover database? Things like open water, things like soil types, right? Those soils, they expand. There's not usually a clear-cut boundary, or even lithologies, geologic rock classifications. They spread pretty far. How can you, at a certain scale, either high level at 30,000 feet or down at 300 feet, how can you clearly deviate or delineate, rather, the line that says this is where this stops and another item begins? So that's where we have to be careful, because ontology and epistemology there, they begin to break down when we get these fuzzy boundaries, as they're called. So that's the big question. From this concept, who gets to decide the categories? Who gets to decide the boundaries? So these are the things you really want to think about as you take Geology 230, as you're doing now. And if you go on and take Geology 233, these are other items that you're going to want to consider and think about as you begin to manage data. Okay, what evidence do we have that we can use in creating categories? See what we're doing? We're getting back to the theory. We're getting back to those hypotheses again. And how do we decide on an application of those observations? Okay, so there's what we're looking at when it comes to ontology and epistemology. Take that a step further. Here's a good example. We're mapping environmental land use, and we're looking at conflicted potential and ecosystem service areas in an agricultural watershed. Okay, so this is actually looking at one of the islands of Hawaii, and we can see on the left-hand side here, we've got annual soil erosion, and we're looking at low importance, meaning very low erodibility, and we look at the browner to redder colors on the fringes, higher importance, okay, higher erodibility, meaning they're looking for more conservation. When we look at agricultural land suitability, Okay, same thing. Low preference is now kind of in this brown to orange color, and high preference is now in this bluish color. Okay, so low to high preferences as we look at these things. And when we look at it from that sort of a standpoint, we have to realize there's going to be overlap. When you combine these two, we end up creating a land use conflict map where we can see that there are low conflict in green. So, hey, there's not going to be an issue here. But as we get out on the fringes, remember, those fringes are going to be defined by how we've classified the soil erosion, and they're going to be defined based on how the agricultural land suitability and use is being defined here within this data set. Okay, but as we get out here and we start getting into the blues again, and we start getting into these reddish orange colors, there's high conflict, meaning this conservation approach and erosion, as well as land suitability, they begin to clash. Okay, now that can change based on how we define those edges. That's the issue with onotology. So keep that in mind as we work forward. We'll touch on this a couple more times throughout the course. So what we want to finish up for this particular lecture is with two more definitions. This first definition of our last two is nature. You said, I know what nature is. I hang out in it all the time. I go camping. I'm in nature all the time. Now, what's interesting is nature, by definition, is actually a made-up word. It's a word that was created by humans. Okay, it's long been viewed as places that are untouched by humanity. That's nature. But more holistically, we think about it as the physical world, including humanity. Do we live in nature? Does nature live with us? Do we live with nature? It just depends. Well, society, our other definition that we want to define here, is the organization of humanity into its many forms. Think about that society standpoint, and then turn around and think about how we define society, and we define society's evolution, right? So this natural nature, society, this natural concept, we have to critique this. The idea of nature is socially produced. It's man-made, as I mentioned earlier. The physical world exists, but there's no nature aside from humans defining it that way. I can go up and I can go to Yosemite National Park, and we can say, it's great to be in nature, but if humans weren't here, Yosemite would still exist. And me being in San Luis Obispo, or me being in Fresno, California, or me being in Yosemite wouldn't be any different, right? Because I'm defining what nature is. Now, the reason why this is important, though, defining nature versus society, thinking about ontological science here, right, is that humans and our impact are so widespread. Think about climate change, think about pollution, think about land use, think about energy types, right? That really, there's no place on Earth that is essentially unaffected by humanity. So if our definition of nature is things that are untouched by humanity, in theory, nature doesn't exist. And as we've already talked about, nature's definition is man-made, so it really doesn't exist. Okay, so you can see how ontology and epistemology come into play and actually break those things down. Now, it's not that I'm not for preserving things. I'm definitely all in the mode of preserving and protecting national parks, etc. But it's just something we have to consider. Which of these things, based on epistemology and ontology, are things that we fight for, maybe even subjectively versus objectively at times, that are by definition a definition that we've described and made up. Okay. Now think about that for a minute, and how would that actually impact you? And you're going, this is a little too philosophical. Let's get to the GI science, move the horse and pony show along. Well, all these things that we've just talked about for the last 20 minutes or so, I want you to consider this. How do these concepts and the terms relate to your discipline? For me, I can look at it, going back to the soil science for a minute, looking at the geology, and I can see how defining clear-cut boundaries based on ontology and epistemology can be challenging in geoscience, right? But what about for yourself, your particular topic of interest, your area of study, or your area of practice if you're employed right now? Okay, how do these concepts, all these definitions that we've thrown out there, actually impact you? I want you to take those and consider that. And with that, feel free to post on a discussion board. You don't have to. This is not a required assignment, but I do want you to consider that. And while you're at it, Consider lingering questions about these definitions. Do you have more questions? Do you have concerns about them? You can have disagreements. That's fully acceptable. But for this class, we've kind of outlined what the key components are. So if you have those questions, I want you to think about how you might be able to apply these concepts into spatial issues, spatial sciences. I've listed a couple as we've gone through the lecture at this point in time, okay? So those are the three things I really want you to consider. Step back, look at those definitions, look at theory, look at structure, look at society versus nature, right? Look at all these things, subjectivity, objectivity, and consider how do these concepts and terms apply to you as far as your discipline and area of study. Do you have lingering questions about the definitions? Are you confused about them? And then also, how might these concepts apply to spatial sciences and spatial issues? A lot of these you'll find are interconnected and interrelated. We'll leave you with that for this first video, and we'll get you ready for the next one. Taking all these terms, I still want you to kind of put that through the funnel and put it through the lens of exploring our world, and do so by exploring our world through GIS and taking these concepts. I promise you, they'll help you. You'll find out some really good stuff as you begin to look at the world through a different lens, but continue looking at it through that lens of GIS. See you in the next video.